Okay, so we're back, and today we are diving into a topic that I think is becoming more and more important and gaining traction.
Yeah, absolutely.
Zero knowledge proofs, ZKPs.
hmm
We've got a really cool paper, scalable, transparent, and post-quantum secure computational integrity.
Yeah.
It's a mouthful,
Yeah, it is.
um, but it gets at the idea of what makes ZK Starks different, and also, what their sort of value proposition is.
Right.
So I think it'd be cool if we could just dive into that and maybe talk about, um, I think we both did a little bit of research on this. I guess maybe to start off, um, let's assume that the listener's pretty familiar with, the basics of ZKPs,
Sure. Yeah. Huh.
and we can kind of go from there.
Yeah. So, I mean, I think one of the first things that really struck me when I was looking into ZK Starks was the fact that they don't require trusted setup,
Hmm.
which is something that a lot of other zero knowledge proof systems really kind of hinge on.
Yeah. And so what's so great about not having a trusted setup? I mean, what does that even mean?
So, a trusted setup basically means that in order to kind of generate the parameters for the system, you need to rely on some sort of trusted third party to generate some secret information.
Yep.
And then ideally this information is then like destroyed or somehow made inaccessible. But there's always this risk that that maybe that information wasn't actually destroyed or that it could be compromised at some point.
Yeah, I mean, I've heard this referred to as, like the toxic waste problem, where
Yeah.
you've got to like get rid of these secrets in a way that
Yeah.
is verifiable.
Exactly. Yeah. It's like a single point of failure.
Right.
And it can really undermine the trust in the system because
Hmm.
if you're relying on these secrets that were generated by some party that you have to trust, then you're basically just kind of shifting the trust from, like a central authority to this, like crusted setup process.
Right.
Whereas with ZK Starks, you don't have that issue.
So how do they pull that off then? How do they do that?
So they use public randomness for their setup. So instead of relying on like these secret keys that are generated by some trusted party, they use random values that are publicly verifiable.
Got it.
So anyone can basically go in and check that the randomness that was used to generate the parameters for the system was actually publicly sourced, and it wasn't like some secret backroom deal.
That makes sense.
Hmm.
So it really gets at the heart of, the trustlessness or the decentralized nature that I think, zero knowledge proofs sort of try to get at anyway.
Right.
So that's really cool that, they can pull that off. What else? What other, big features sort of differentiate these?
I think the next one that's really important to highlight is the scalability of their verification process.
Right.
So basically, one of the big advantages of ZK Starks is that the time it takes to verify a proof scales sublinearly. Or even exponentially faster compared to the size of the data or the complexity of the computation that you're trying to verify.
Okay.
So if you're dealing with, like really massive data sets or like really complex computations, traditionally you would have to either rerun the whole computation yourself or like check all of the data in order to verify that it was done correctly,
Right.
which obviously would take a really long time.
Yeah, and I think especially as we're moving into this world where we've got so much data, that's becoming increasingly difficult to do.
Exactly. Yeah. So ZK Starts kind of offer this way to very quickly and efficiently verify the integrity of a computation without having to actually like go through all of the data yourself.
That's amazing.
And it's interesting because the concept of having like a transparent zero knowledge proof with fast verification was actually theorized like back in the 90s. But it wasn't until like very recently with ZK Starks that we were actually able to like realize this in practice.
So what was it about ZK Starks that sort of made that possible?
I mean, there were a lot of like technical innovations, but I think one of the key things was just like, the way that they designed the system, the underlying mathematics. It just made it a lot more efficient.
Okay.
And so that allowed them to achieve this fast verification.
And the paper talks about these time rates and these witness size rates. Can you unpack that for me a little bit?
Sure, yeah. So these are basically just metrics that are used to quantify the efficiency gains that you get from using ZK Start. So the time rate is basically just the ratio of the time that it takes to verify the ZK Stark proof to the time that it would take to verify the computation directly.
Right.
And the witness size rate is the ratio of the size of the ZK Stark proof to the size of the original data. So if you have a time rate or a witness size rate that's less than 1, that means that, ZK Starks are more efficient.
Gotcha.
But there is like a kind of a threshold where, for smaller computations, the overhead of actually generating the ZK Stark proof might outweigh the benefits of the fast verification.
Right.
But as the size of the computation grows, the benefits of ZK Starks become more and more apparent.
So I'm looking at figure 1 in the paper here.
Yeah.
It's showing these time rates and witness size rates for like a DNA profile matching problem.
Right.
And it looks like beyond a certain point, both of those rates drop off pretty dramatically.
Yeah.
So that's a pretty cool example of how these rates kind of play out in practice.
Exactly. Yeah, and that particular example is actually really interesting because it highlights one of the areas where ZK Starks are particularly well suited, which is for computations that are kind of like sequential in nature. So like in the DNA profile matching example, you're basically like you're comparing the DNA profile of like a suspect to a database of DNA profiles.
Right.
And so it's like a very kind of step-by-step process.
Got it.
And ZK Starks are really good at handling those kinds of computations.
So we talked about how they don't require this trusted setup and they're really scalable. What else kind of jumps out at you about ZK Starks?
I think another thing that's really important to mention is that they're post-quantum secure.
Ooh. That's huge.
Yeah. So as you know, like quantum computing technology is advancing, and there's a lot of concern that a lot of our current cryptographic systems could be broken by quantum computers.
Right.
But ZK Starks rely on cryptographic assumptions that are thought to be resistant to attacks by quantum computers.
So that's like a big deal for anyone who's thinking about the long-term security of their systems.
Exactly. Yeah, it's a really important consideration, and it's something that a lot of other zero knowledge proof systems are not necessarily designed to handle.
I mean, it seems like this is a rapidly evolving area, but like these guys are already one step ahead.
Right. Yeah, they're kind of like future proofing in a way.
Yeah, that's really cool. So we've talked about a lot of these sort of advantages, but I mean, like, how universal are these?
Yeah.
Like, can they be applied to just any computation?
Yeah, that's another great thing about them. They are universal. So they can be applied to pretty much any computation that can be expressed as a circuit.
Okay.
And they're not limited to any specific type of computation. Like some other zero knowledge proof systems might be like tailored for like a specific type of computation, like like proving that you have a certain amount of money in a bank account or something like that.
Right.
But ZK Starks are a lot more general purpose.
So that really expands, their applicability. And I know we've been talking a lot about sort of like the technical underpinnings and the advantages, but I mean, like, what does this all actually mean for the average person? Like, how does this impact, their lives?
Yeah. So I mean, at the end of the day, like the main benefit of ZK Starks is that they allow you to verify the integrity of information without having to actually see the information itself. So this is really important for privacy.
Okay.
For example, like let's say that you want to prove to someone that you're over 18 without actually revealing your date of birth.
Right.
You could use a ZK Stark to do that.
Why?
Or let's say that you want to prove to someone that you have enough money in your bank account to make a purchase without actually revealing your account balance.
Yeah, that's a great example.
You could use a ZK Stark to do that too.
And so, like, in those examples, like, what would the other party actually be seeing?
So they would basically just be seeing a proof. And the proof would basically just say, like, yes, this person is over 18, or yes, this person has enough money in their bank account.
Got it.
But they wouldn't actually be able to see any of the underlying information.
So it's like a really elegant way to kind of like thread that needle of privacy and also verification.
Exactly. Yeah. It's like a really powerful tool for protecting privacy.
So we've been using this term like zero knowledge proofs, but like I think it would be good to kind of just reiterate like what exactly we mean by that.
Sure. Yeah. So zero knowledge proofs basically allow one party to prove to another party that they know something without actually revealing what they know.
Okay.
So it's like, like let's say that I have a secret password.
Right.
And I want to prove to you that I know the password without actually telling you what the password is.
Right.
I could use a zero knowledge proof to do that.
And how would that work,
Yeah.
like in that example?
So basically, the zero knowledge proof would just convince you that I know the password without actually revealing any information about the password itself.
Right.
So it's like, you would be convinced that I know the password, but you wouldn't actually learn anything about the password.
That's amazing.
Yeah, it's a really cool concept.
Yeah, it's like magic almost.
Yeah.
And so how does ZK Stark specifically kind of fit into this whole idea of zero knowledge?
So ZK Starks are just one type of zero knowledge proof system.
Gotcha.
And they're kind of like a relatively new type of zero knowledge proof system.
Okay.
But they're really powerful because they have all of these advantages that we've been talking about, like the transparency, the scalability, the post quantum security.
Right.
And so they're really well suited for a lot of different applications.
So we've kind of touched on this a little bit, but like I'd be curious to know, like, what are some of the most promising applications that you see for ZK Starks?
Yeah, so I mean, I think one of the biggest areas where ZK Starks could have a huge impact is in the area of blockchain technology.
Wow.
Blockchains are basically just like these distributed ledgers that are used to track transactions.
Right.
And one of the big challenges with blockchains is that they can be really slow and expensive to use.
Right.
Because every time you want to add a new transaction to the blockchain, you have to get like a majority of the nodes on the network to agree on it.
Yeah, it's like this consensus mechanism that's like really computationally intensive.
Exactly. Yeah. And so ZK Starks could be used to make blockchains a lot more efficient.
Okay.
Because they could be used to verify transactions without actually having to like process all of the data on the blockchain.
Wow.
So this could potentially lead to like much faster and cheaper blockchains.
That would be a game changer.
Yeah, it would be huge. And I think there are a lot of other potential applications for ZK Starks as well. Like in the area of healthcare, they could be used to share medical records securely, or in the area of voting, they could be used to create secure and verifiable voting systems.
I'm starting to see how this could, impact so many different industries.
Yeah, I mean, I think the potential applications are really limitless.
So what are some of the challenges, the limitations of ZK Starks? Like, are there any downsides?
Yeah, so I mean, I think one of the biggest challenges with ZK Starks is that they can be quite complex to implement.
Okay.
So like the underlying mathematics is pretty advanced.
Right.
And so it can be difficult to actually like write the code to generate and verify ZK Stark proofs.
I see.
But I think like as the technology matures, those challenges will become less and less significant.
And, I'm wondering too, like, with all of these different applications that you've talked about, like, is there a concern that ZK Starks could be used for like malicious purposes?
Yeah. So, I mean, that's always a concern with any new technology.
Right.
Like any technology can be used for good or for evil.
Yeah.
And so it's really important to think about the potential implications of ZK Starks and to make sure that they're used responsibly.
Yeah, I mean, I think that's a really good point to end on.
Yeah.
This has been a fascinating discussion about a topic that's becoming increasingly important.
Yeah.
And I think ZK Starks are a really exciting development in the field of zero knowledge proofs.
Definitely.
So for our listeners out there, we encourage you to learn more about ZK Starks and to think about the potential ways that they could be used to improve our lives.
Yeah, absolutely.
So thanks for joining us on the Deep Dive.
Thanks for having me.
And we'll see you next time.